And we are live. Yes, because I have a dog with me this time. She's warm. I'm cold. I'm in my basement. And I don't really want to put her down because she's warming me up. Thank you. So we'll see if she can find any other ways to help us during this lesson. I think I might be able to think of some problems involving percent change that involve Mocha the dog so that she can really participate. But until then, I'm going to put her down on her little comfy armchair. Lie down. Stay. And I will point out there's nothing interesting to talk about with the weather, so I won't. I'm wearing a Barcelona jersey. You know that happens quite often. Let's get into the math. Okay, welcome to Math with Doug. Welcome to Percent with Doug. Welcome to Percent Change with Doug. Okay, what is percent change? It's a math trick we do that allows us to figure out by what percentage something has changed. Sounds like the name, doesn't it? Okay, so how do we calculate it? Percent change is equal to new minus old divided by old times 100. Okay, so times 100 makes sense because we want a percent as our answer. And then why are we doing new minus old over old? What we're doing in the numerator is we're finding the difference between a number that changed before and after the change. And then we divide by old because it is comparing the change to the old number that gives us an indication on our answer of how it changed. I don't know if that was the clearest definition I've ever given, but I'm just going to ride with it. Okay, so we will do some examples. We will start with just some pure numbers, and then we'll get into some examples that have some sort of meaning to them. Kind of word problem-y, but don't hold your breath waiting for me to start writing big paragraphs on the chalkboard wall in this lesson because I won't. Okay, let's start with this one, 42 something. Now I have notes, but my notes are on my laptop screen right here, so I will be consulting that once in a while. The reason I have to consult it now is I want to know how the number 40 changed. And of course I didn't write the number it changed to ahead of time because I know students will figure out the answers to everything that's written on the chalkboard wall before the teacher can even have a chance to start talking. So 40 is changing to 32. Now we know how it changed. Now we can calculate the percent change. So we're doing this to these numbers. So the new number is 32. So it changed from 40 to 32, just to give us some context. The new number is the 32. And we subtract the old number, which is the 40. And then we divide the answer to that subtraction by the old number, which is the 40. And we multiply by 100 so that we'll get a percentage at the end. I may run out of space over here, which is why I left a bit of space below. In fact, I'll just go equals. Okay, 32 minus 40 is negative 8. So we have negative 8 over 40. It's a negative number. And I know I might be teaching this to some students who haven't really done their integers yet, where we deal with all the negative numbers. But the negative numbers are just involved a little bit in this lesson, and I know the students can handle it. We have negative 8 over 40, but we still have to multiply by 100. What is negative 8 over 40? That is negative 0.2. I'm just converting this into a decimal and dividing. Negative 8 divided by 40 is negative 0.2. Double check my notes. And I'm still multiplying that by 100. So that is going to give me a negative 20% change. And then we discuss why is the negative sign there? Why do we have to have the negative sign there? It means that we have a 20% decrease. When you say it this way, you don't really have to write the negative sign in your answer. A 20% decrease is negative 20%. So the negative sign is useful because it tells us whether the change was for the new number to be smaller than the old number or to get larger than the old number. That might seem kind of obvious that 32 is smaller than 40, but we have to incorporate that into our calculations somehow to make sure that the answer is clear. So we have a 20% decrease when we go from 40 to 32. And then doing that, I didn't really leave any room for my second example, so I'm going to have to do some erasing. But that's all there is to it. It's not a very long process. And the way we calculate percent change keeps on being the same all the time. And that is one of the points to this. Why did I make the 32 go first and subtract the 40? You might think, why wouldn't I just say 40 minus 32 equals 8 and avoid the negative numbers? Because having it set up this way where we always do new minus old allows us to deal with a situation where the number got smaller or a situation where the number got larger with the same formula. It makes the formula more powerful. It makes you not need to memorize two different formulas that you use in two slightly different situations. Checking the time. Okay, so that didn't take long, and I knew it wouldn't. I'm going to erase, and we're going to do another one, which is going to involve this 30, but I have to check my notes to see what the 30 is going to change into. So first I'm just going to erase the 40 to 32 question altogether and its answer, make lots of room, and let's do another example. One example is never enough. 30 is changing to, oh, that's the end of that chalk. The percent change in this piece of chalk since yesterday is a decrease. So enough of that piece of chalk. Let's get a fresh one. Like magic. Okay, 30 changed to 45. So we're doing our formula. The 45 is the new. We subtract the old, which is 30. And this time, the bigger number comes first. So I'm not going to get a negative number when I subtract. But that makes sense because 30 becomes 45. 45 is bigger than 30. And then I put the old, which is the 30. I multiply by 100. Okay, 45 minus 30 is equal to 15. 15 divided by 30 also has to be multiplied by 100. 15 divided by 30 in decimal form is going to give us 0.5. Which when I multiply it by 100 will give me a 50% increase. Now I could put a plus sign there if I want. I need the negative sign when it's a decrease, but for an increase we can see, oh, 50%, it's not negative, therefore it's a 50% increase. And I will just write that in brackets as well. So it's important to note that when you calculate percent change, you realize that sometimes it can be an increase and sometimes it can be a decrease, and that you kind of have to say so if you want whoever sees the answer to your formula to understand what it means. So 30 to 45, we have a 50% increase. Let me look at my notes. I'm taking all this time to look at my notes because I'm realizing that my answer in my notes is different than my answer that I just did. And I was double checking it, trying to figure out where the mistake was. And I'm very happy to report that the mistake was in my notes and that I did it correctly here. So that means I don't have to stop the camera and start filming all over again. Phew. Okay. So this is not a very complicated thing to do, but we don't only practice something twice. We need to practice this a bunch of times and see if we need to ask those what if questions to see, okay, well, what if this happens? What if that happens? That can be a good thing to do, because when you only see two examples of something, that's not enough. And what will happen if you operate without enough examples is you'll move on to another time when you need to do this, when it's important, and then something unexpected will happen and you won't be sure what's going on. You won't know if you're correct or not. If you practice enough and you see all the things that can happen and you ask those what if questions, well, then that can't hurt you. No matter what happens when you do it later, when it's important, you'll be ready for it. That's my strategy anyway. That's my explanation for why math students should practice a lot. As many examples as you can manage. When something takes half an hour to do, you can only do a few examples. But when something only takes 3 minutes to do, you can do many examples. So do many examples of this. It doesn't take long to do it. Let's move on to my next example. And I guess I can get into the goals, last season goals, this season example that I am clearly prepared for. So I'm going to do that. And again, I didn't say how many goals last season or this season on purpose, because if I had put the numbers there, all of you would have already calculated it, and then I'd be talking about it for nothing. Okay. Erasing that example. I think I want to keep this here for the whole lesson, because I think I have room. These examples don't take that much space. Okay, the goals one. Now, goals in what sport? Who cares? I don't even know. It could be soccer, it could be hockey, it could be what other sports do they have goals? There are plenty of them. All right, so we have some goals last season and goals this season. And last season, the number of goals was 47. So maybe this is one player who scores a lot of goals who got 47. Maybe it's a team, I don't know. Doesn't matter, because we really want to focus on the math. And the goals this season, 9. Okay, so whether it's a single player or a team, the goal production has gone down. And of course, we can see that without calculating percent change, but let's use percent change as a way of showing how much the goal production has changed. So let's do our calculation. It's that fast. New minus old, 9 is the new, minus 47 is the old, and then I'm dividing by 47 because that's the old, and I have to multiply by 100. 9 minus 47, that's going to be negative 38, right? Don't have a calculator handy over 47, but of course as students you should have a calculator handy and use it when you need to. Yes, minus 38 according to my notes is the correct answer, but of course we all know that my notes aren't always right. Times 100, still have to do this. Okay, what's negative 38 divided by 47? I'm going to use the calculator for that. Even though I already wrote down the answer, I'm still going to use the calculator because I know the students who are learning how to do this don't have the answer already written down ahead. So let's go through the whole process. 38, negative 38 divided by 47 equals, and we have one of those decimals that goes on forever, so we have to do some rounding. How high should I round? I'm going to start writing the decimal. Negative 0.8085, 0.8085, 10638. I'm just going to write it to the 5 and stop there. Now, why did I choose to go to 4 decimal places? Because I realize I still have to multiply by 100. So I don't want to round this to, say, negative 0.8. Because then when I multiply that by 100, I'm going to get an answer that's not as exact as if I round to further decimal places. Why is 4 enough? Because multiplying by 100 is going to cause the decimal to jump forward 2 positions. And there is still some numbers after that. So we can have an answer that's more meaningful, and it's meaningful enough. So you look at the math that you're going to do, you predict what's going to happen, and you try to round your numbers in a way that works so that you retain accuracy. Okay, so we have negative 0.8085 times 100. Which, when I multiply it, is going to give me negative, negative 80, it's a messy 8, 0.85%. So this is a decrease of 80.85%. Depending on how I round it, it could have been a negative 81%. And some people would say that's accurate enough. Or it could have been negative 80.9%. So long as we're not rounding incorrectly, these are all valid ways of answering this question. Overall, though, what we have, I'm going to use the negative 80.9%. That's the one I like the best. I like rounding to the nearest tenth quite often. So I can say that is an 80.9% decrease in goals produced by whoever this was. Did all of that fit on the rectangle of the video? Yes, it did. Okay, and how am I doing for time? Not too bad. I should be able to fit in quite a few extra examples. Okay, so we have an actual situation, and then there's some meaning. Okay, someone's goal production decreased by 80.9%, almost 81%. That's quite a decrease. Okay, so within a situation, we can find the numbers that matter, we can fit them into this formula, and then we can report on something that explains what happened. Percent change is useful for that. put down the calculator and let me look at my notes for another one. Now I have golf scores, I have bowling scores, I have something with money. I think I should use something with money. Percent change is used for situations involving money quite often. So let us do some erasing. And of course, while teachers are erasing and writing new examples, remember students can always stretch. And if you need some hydration, you can take a sip of your fizzy water like this. This is vanilla cherry flavored fizzy water. Okay, erase the goals. Leave the formula there, erase the whole answer. And remember, yes, we have this issue involving decimals when we're in the middle of our calculations, and sometimes we have to make decisions about rounding along the way. Okay. Money. $40 last time, $80 now. So I'm just going to write that information here. So a situation where this could happen is I could have gone to buy something, like I could have gone to the place where I buy my exotic hardwoods for my woodworking hobby, and last time I spent $40. But this time I've spent $80. And of course there could be many reasons for that. Prices could have gone up, but that would be an awfully big increase if the two times were close together, or it could be that I just chose to buy more expensive things. All sorts of different reasons that this could happen, but let's calculate the percent change because that's what we're here for. So new minus old is 80 minus 40, and then old is the 40. Times 100, 80 minus 40 is 40 over 40 times 100. So here's an answer to one of those what if questions. What if you do this part and it turns into a fraction that's equivalent to 1? Well, 40 divided by 40 in decimal form is 1. Or if you want, you can say 1.0 times 100. And that's going to give us 100%. So a 100% change has happened. But we need to say increase. So for whatever reason I was spending that money, there has been a 100% increase in how much I spent between last time and this time. Percent change tells us that. Another one involving money. Okay, so I did a job that involved planting things, and I was paid by the number of trees I planted. And I did the job once in the past, and I only made $40. Oh, $40 last time, $40 last time. Hey, I put $40 last time on both of these examples. That's fine, that saves me a bit of writing, okay. So this is a different situation. We still have $40 last time, but now this time, the amount is $365. That's a big difference. So we just saw an example where we ended up with a 100% increase. 100%. Just that, maybe it's a coincidence. This time, the number has changed by a lot. So let's calculate percent change so we can explain how it's changed. New is 365 minus old, which is 40, divided by old, which is 40, times 100. 365 minus 40 is 325 divided by 40 times 100. Okay, a bit more chalk please. 325 divided by 40, and again I'm reaching for my calculator even though I have the answer written over there. 325 divided by 40, 8.125. It's tempting with a question like this to jump ahead and start saying, it looks like an 8.125% increase. And clearly it's an increase. Look at this situation. But no, I haven't multiplied by 100 yet. So this number is bigger than I was getting in a lot of my previous examples, but because that's happening because the difference between new and old is so much bigger this time. So I end up with a number that already has a non-zero digit to the left of the decimal, and I haven't even multiplied by 100 yet. So therefore, you look at my answer as well. Yes, 8.125 times 100 is an 812.5% increase. So maybe the last time I planted trees was a long time ago, because I only made $40. And now I've made $365. That's an 812.5% increase in the amount of money I earned. Interesting. So I wanted an example like this because I wanted the students to see situations where you end up with these percentages that are over 100%, and in this case quite a lot larger than 100%. It can happen. It just depends on the numbers that you have. It depends on the hand you are dealt. Okay, so there's a couple of examples that involve money. And I'm looking at how much time I've used. I'm wondering if I should start incorporating Mocha into the lesson plan. And that means I am improvising, because I did not prepare, and my notes do not mention a dog. I did not prepare any examples ahead of time with her, but as I was bringing her down the stairs, getting ready to teach this lesson, I started thinking of an idea of numbers that actually matter, the real numbers that actually have existed involving this dog, and I thought, let's calculate the percent change. So let's do that. I'm going to erase this whole tree planting example, regardless of its profitability. And let's talk about some Mocha numbers. Yes, Mocha, yes, like the chocolate because of her color. And we thought if we ever get another dog, we want to call it Chino. So we have Mocha and Chino. And we can go outside and yell, Mochaccino! And it'll actually have a purpose other than just, wanting a mochaccino to drink. All right. So, speaking of drinking, I'm taking more of a sip of my fizzy water. Let's think of these numbers. Okay, I'm ready. When we got Mocha, she weighed 4 pounds. She was a tiny little thing. I carried her on one arm with her legs on either side, and she just fit on my forearm really nicely. And she was very confused because she grew up until that point in a place where really she didn't see very many humans, and she saw a lot of dogs. It was a breeder's that specializes in her breed. So a lot of little dogs, quite cute. And she wasn't very used to humans, but I just scratched her behind the ears while Bunny was doing all the paperwork, and she seemed to bond with me, because I'm telling you, she was supposed to be Bunny's dog, but no, she's my dog. Just ask her, she'll tell you. Okay, so she weighed 4 pounds. She was a little thing. Obviously now she weighs a little more than that. Lie down. See, she knows I'm talking about her, so she gets all distracted and she thinks it's supper time. It's not supper time. There's quite a lot of time left in this math lesson. Okay, then she gained weight. And we knew that she was supposed to weigh about 14 pounds when she was an adult. But when we brought her to the vet one time and she was weighed, it turned out that she weighed 19 pounds. All right, puppy and adult. So what that meant was the vet was breaking the news to us that our dog was overweight. And then the vet started giving me advice about how to get her to lose weight. But we'll get to that because her weight changed more than once. And we're just talking about the percent change between puppy and that first adult weigh-in. So we have the information we need to do this. The new is the 19. And the old is the 4, and the old is the 4, and we're multiplying by 100. So I hope we're getting good at this by now, because it starts to feel very comfortable once you've had enough examples to practice with. 19 minus 4 is equal to 15. 15 over 4 times 100 Can I be a show-off and do 15 divided by 4 in my head? 15 divided by 4 is 3.75. How do I know that's right? Well, 12 divided by 4 is 3, and 15 minus 12 is 3, and 3 divided by 4 is 0.7. Yes, I feel very confident that I have it right, but I still have to multiply it by 100. Equals a 375% increase. Oh boy, our dog underwent a 375% increase in her weight in only about a year and a half. But the thing that mattered was the vet knew, because the vet knows this breed, and we knew because we had found out earlier that she wasn't supposed to weigh that much. And we realized we have to put her on a diet. So the poor thing had to go on a diet, and then her weight changed again, and that's going to be our next example. So I will erase this example, and I will leave some of this up here because we can use it again. So 375% increase. I'll write that over here so we can remember it. Increase. Okay, let's erase this example. And then we will erase the word adult and the 19 and the 4 and the word puppy. Because before diet and after diet will be our next pair of numbers. So you know what I mean by diet. The dog was on a diet, the dog had to lose weight. After diet. Now, how did we achieve this? It's hard to do yourself, because when you need to lose weight, you have to have some self-discipline, and you don't always really want to have self-discipline. But if you, for instance, drink the sugary soda pops and you switch to these fizzy waters, that should make a difference. And they taste quite good, so that's one way. But of course, Mocha didn't drink soft drinks before or after. So what we did, the vet advised us, a very cute little piece of advice. Put her food in a ball, or one of those things that dogs play with that have food in it. So she has to exercise to get her food. So that is one change that we made. I have several of these balls, different sizes and shapes, that I can hide her food in, and then she has to work for a little while to get it, and forces her to exercise. Another thing was to use less food every time I fed her. So I went from almost a cup of food every morning and every evening. She gets 2 meals a day. And it's just an ordinary dry food, a healthy dry dog food, to 3/4 of a cup. And I just have always done it that way ever since. And it worked. It took almost a year. We weighed her a couple of times in between, and we wanted her to get down to at least close to the target weight. She's supposed to weigh about 14 pounds, being a female of this breed. So we had the 19 pounds now becomes the before. That was the weight that she had that was too heavy before the diet. And then after a year, when we brought her to the vet, I crossed my fingers and the vet weighed her, and she weighed 15 pounds. Still a little more than she's supposed to. And that was after a very disciplined dog diet for a whole year. So let's calculate the percent change. The new is the 15, the old is the 19, and then we subtract. Now remember, the new was the 19 before, but that was a different situation. We're into a new situation where we're starting with the 19 and we're saying, how did it change to get to the 15? 15 minus 19 divided by 19 times 100 is equal to -4, so we get a negative number because her weight went down. There's going to be a decrease, and we get used to this. Whenever there's going to be a decrease, we're going to see ourselves subtracting the larger number from the smaller number and getting a negative number in the numerator right here. -4 over 19 times 100, and I really am going to grab the calculator because I don't have notes that say the answer. I don't actually know what the answer is going to be. I was a little surprised at 375% increase from the last one. Woo! That dog was really into the food. Okay, -4 divided by 19. have to do some rounding. It's one of those decimals that goes on and on. So we got negative 0.2105. I'm just going to put negative 0.21. I know I'm going to jump the decimal 2 places, and then the next number after the 1 being a 0, I'm thinking, it's going to be good enough. Negative 0.21, but I still have to multiply by 100. So I have negative 21%. It's a little smudgy, which means a 21% decrease. It was so easy to let this huge 375% increase in her weight happen, and it was so much hard work. No, I'd say she's the one who did all the hard work, because she just thought she was hungry all the time. She thinks we're torturing her by not giving her enough food. She still feels that way to this day, because we maintained that 3/4 of a cup portion size indefinitely till now. And I would guess she still weighs about 15 pounds right now. She hasn't been weighed recently. But I'm very proud to say that after we decided we had to put her on a diet, she underwent a 21% change, a 21% decrease in her weight, and then she kept the weight off. Very good dog. Now, if she had thumbs and had access to the refrigerators and such, we would have a very big dog on our hands, I'm telling you. She just thinks she's starving all the time. And she'll eat. When I'm planting in the garden, when I buy the bags of new soil, that lovely black soil, she eats that. I have to put fences around my garden beds so that she doesn't go browsing around them eating the soil. She thinks it smells good. So, dogs are like that. Anyway, that's enough with the Mocha examples. We have a context, a word problem sort of context there, which I wanted to have happen. I don't want it to always just be straight numbers. How am I doing for time? I'm doing fine for time. So I'll be able to do several more examples, quite a few more examples, and I might have to improvise some of them. But I have 4 others that are prepared. I'm going to get into those first, and I'll worry about the time later. So, this overweight dog, who's not quite so overweight anymore, is going to have to wait for her supper tonight another 27.5 minutes at least. Okay, so what's my next one? I'm back to the scores in sports or games, because I don't know, I like that. And I wanted to mention, I think I'm going to do the example with the bowling scores first. So bowling scores is actually going to be our next 2 examples. I'll just put a little heading, and instead of writing that paragraph for word problem, I'll just give the information over here and leave it there while we do the calculations. So the bowling scores last season, so I'm going to call bowler A. Last season, and later we'll do bowler B. So get ready for bowler B, who also had a score last season. Let's see how this is fitting into the video rectangle. It's fitting pretty good. Last season, bowler A's average was 154. And we'll see if this fits into the video rectangle. Oh, it does. It looks all crooked, like I'm writing downhill. It's that tilt of the camera. I'm just not going to let it distract me. 154 average, but this season, I'll put it like this. I'm really using a lot of styles in how I write this information. Ooh, 168 average. We're not going to talk about bowler B yet, because I know what you're like. You're going to calculate bowler B before I finish talking about bowler A. Okay, so, but I need this season for bowler B, just so I'm ready. And I think when I write in bowler B, I'm just not going to use the word average. I'm just going to let people realize, yes, I'm talking about the averages. have to write a little bit less. Okay, so 154 to 168. We can tell already, I know what you're thinking, that's going to be a percent change. That is an increase. We're going to get a percent increase. We all know what to do, but we're going to do it. 168 is the new, minus 154 is the old, divided by 154, which is the old, times 100. 168 minus 154 is going to be 14 over 154 times 100. I need to convert that into a decimal. 14 divided by 154. Yes, I have the answer written there, but because I already made one mistake in my notes, I'm going to use my calculator. 14 divided by 154. Oh, I like this decimal. 0.09090909. So it's 0.09 repeating. We know how to deal with decimals, so we know that happens sometimes. Or I could write 0.0909. But I still have to multiply by 100. That makes me want to go to 4 decimal places. So I'm going to write 0.0909. I have rounded to the nearest 10,000th. And the next number after it is a 0, so I'm good to stop there. When I multiply by 100, it's going to give me 9.09 or 9.1%, and that is a 9.1% increase. Does that match my answer from before? Yes, it does. I got it right both times, I hope. Okay, so that's Bowler A. I'll write here, 9.1% INC, just to summarize our answer into that information. So, because we're going to talk about Bowler B, and we can compare Bowler B and Bowler A. But I'm going to erase this to make room for Bowler B's numbers. Okay, Bowler B last season, 114. Bowler B this season, 77. Okay, so Bowler B had an average of 114. Double check my numbers. Yes. And this season, an average of 77. So we see there's going to be a percent change. That's going to be a decrease. Because last season is the old and it's bigger than the new. Here, A, the average score went up. A is improving. B does not look like they are improving. Let's erase the calculations for A and do the calculations for B. Okay, so new minus old, that's 77 minus 114 over old, which is 77, and we're multiplying by 100. 77 minus 114, that's going to be 37, isn't it? 23, yes. No, it's not going to be 37, Doug. It's going to be negative 37, negative 37. Yes, of course, it's going to be a percent decrease. This is what the negative sign is telling me. It's one of the ways to figure out that it's a percent decrease. That's not the only way. And that's still going to be divided by 77 and multiplied by 100. Leave some room. Okay, so if you think negative 37 divided by 77, let me double check my notes. Old. No, I did it wrong. New minus old, 77 minus 114, and it's supposed to be over old. I made a mistake. And this time my notes had it correct, so I made the mistake now. Something seemed funny about that. Okay. Yes, old is last season, so that's 114. Now we're going to do the division with the calculator. Negative 37 divided by 114. Oh, negative 0.32456. I'm going to call it 325. So I rounded to the nearest thousandth, and I had to round up in this case because the number after the 4 was a 5. Okay, negative 0.325 times 100, which is negative 32.5%. which is a 32.5% decrease. It's hard to write this low in the chalkboard wall. Is it all fitting? Yes, it is. Decrease. Okay. So now we can really compare these two bowlers in different ways. You can just say all their averages and people will get the idea, but Bowler A had a 9.1% increase from last season to this season, while Bowler B had a 32.5% decrease. So who did better? In bowling, a higher score is better. Higher average is better. A percent increase means Bowler A is improving and Bowler B is not improving. Bowler B is becoming less skilled as a bowler somehow. Okay, so there's my bowling scores examples. How am I doing for time? I'm doing pretty good for time. I'm going to do golf scores. Golf scores. Let's do golf scores example. Erase, erase, erase. I'm going to keep the word scores. There. Erase all this stuff. Okay, golf scores. Okay, what information do I have? This time I'm not going to do averages for a whole season. I'm just going to do games. So last time they played, who knows how long ago, golfer A had an 84 as a score. And I'll use an arrow to show that then, after the 84, so more recently, golfer A had a 91 as a score. Golfer B, this time I'll give all the information right now. Golfer B had an 88 as the score last time, but then this time, golfer B got an 85. Okay, so let's find the percent change for both of them. So golfer A, new minus old, 91 minus 84, over old, which is the 84, times 100. Notice how I'm writing a little bit smaller this time. I'd like to be able to do both examples and have them both showing at once. Is equal to 91 minus 84 is 7. Yes, 7 over 84 times 100. Still going to need to move down the line. 7 divided by 84. Calculator. Double checking with my notes. 7 divided by 84, so I know what to expect, but I'm still doing it. 7 divided by 84. It's like when you have someone helping you and you both have a calculator and you say the numbers and the person starts typing it into the calculator, but you really want to do it yourself too. You want to make sure you get the same answer as them. I go through that all the time in my classroom with my students. Okay, so we have 0.083333. We have a repeating 3. I'm looking at my notes. I wrote it too small in the notes. Okay, so we have 0.083, and I'll just round to the nearest thousandth. The next number after the 3 was another 3, times 100, which when I multiply is giving me an 8.3%, and it is a percent change. It is a positive 8.3% change, or I can say an 8.3% increase. So golfer A's score increased. There. Golfer B. Prepare for my handwriting to become more messy. I'm writing too low on the chalkboard wall. 88 to 85, so the new is the 85, minus the old, which is the 88, divided by the old, which is the 88, times 100, equals, 85 minus 88 is negative 3 over the 88, times 100, equals, calculator time, 3 divided by 88. Notice how I didn't say negative 3. 3 divided by 88, I didn't press the negative. But I know that it's negative 3, so I know my answer has to be negative. Negative 0.034090909. So we keep on repeating decimals more often than I would have expected to happen randomly, because these numbers are created randomly. Well, except for the numbers about Mocha's weight. Those were real numbers. Okay, 0.034 is enough for me. Times 100 is going to fit. It's going to fit. Therefore, negative 3.4% is the percent change. It is a negative 3.4% change, which means a 3.4% increase. Messy. Okay, did it all fit? Yes. Okay, so the only thing left to say is to analyze the situation. Now we have a useful statistic, if you will, a useful value to use while describing what's happened with these two golfers. And we look at it and we realize that there is an 8.3% increase in golfer A's score, and there is a 3.4%, I wrote increase. Why did I write increase? Another mistake. Decrease. I know all the students watching this were saying, decrease, why did you write increase? Decrease, decrease, but I couldn't hear them. Again, if the students are in the classroom with me, I would hear them. Okay, so a 3.4% decrease versus an 8.3% increase. So who did better? I can't tell you how many students I've met who would say, golfer A did better, golfer A improved, and golfer B got worse. No, it's golf. You want your scores to be low in golf. That's why I chose to put a golf example here along with the bowling, because some situations you actually want smaller numbers, like your dog's weight if she's overweight. And other situations you want the numbers to increase, like your dog's weight if she's a puppy and she's growing. It should be an increase. But the golf thing is, I like to do that on purpose, to stop the students and make them think, okay, it's not always an improvement when numbers get bigger. Some situations it's an improvement when numbers get smaller, and golf is one of them. Okay, so that's it for that example. How am I doing for time? I'm doing too well for time because I wanted this lesson to be an hour long, and it is not an hour long. So I'm going to have to make up some more examples, because if it was just a little bit shorter than the planned hour, I would say, okay, that's enough, I'll stop. But I'm only at 47 minutes. So I'm going to erase everything except for the formula, and I'm just going to do some calculations. But I think I have an idea. I have an idea of something useful I can do with a couple of examples here at the end. One of the ones I liked the most when I was making up examples for this lesson was, and I have to remember what the situation was, it was one of the money ones. Oh yes, when the $40 for tree planting increased to $365. Because it was such a huge increase, we ended up with a percentage that was well over 100. We had an 812.5% increase in that example. So I want to do that again. So how did we make that happen? Well, I'm going to remind you. I'll write the formula. I won't fill it in. I won't write the answer. I'll just write the formula. We know the answer is an 812.5% increase. We had 365 minus 40 over 40. So when the first number is a lot bigger than the second number, sorry, when the new number, I shouldn't say for second because that's misleading, that's backwards. The new number is a lot bigger than the old number. You end up with something like, and well, I'll write times 100 because I want to keep this accurate looking, but you end up with something like an 812.5% increase. And one of the things that happens when students study percent is that it's important to realize that it's okay sometimes to have answers that are way more than 100%. If we were trying to give grades on a report card and it was all supposed to be percents, and 100 is supposed to be the highest grade someone can get, then we would know there is something wrong here. But that's within a narrow situation where 100% is the maximum. 100% isn't always the maximum, and percent change is one of those situations. So I'm going to do another one, and I'm just going to use the pattern and the numbers to make it happen. So I see, okay, if the if the new is much bigger than the old, I should be able to make this happen. So let's do it. I'm going to say, I don't want to use numbers the same sizes. I want to juggle the situation. So I'm going to say, how about I make 50 my new, and I need it to be much bigger than the old, so I'm going to make 2 my old. No, I want to make it 2.4. Oh, a decimal. That's also a useful thing to do when you do lots of examples, is what about when there's a decimal already in the question? We have a lot of decimals in our answers, but can you have a decimal already in the question? That sounds like it could be a mistake. It could be something you want to avoid. With some types of math, sticking decimals into situations could make things more confusing, but that's one of the magic things about this topic that we're on, this unit, the percent unit. With percent, having decimals creep in all sorts of different places doesn't really cause any problems. When we have our technique and we know how to apply this formula, for instance, we don't let the decimal bother us, and I like that. So the new is the 50, the old is the 2.4. I'm filling in the formula, so 2.4 has to go down here. 50 minus, times 100, sorry. 50 minus 2.4 is 47.6 over 2.4. And I still have to multiply by 100. Where am I looking? I'm looking for my calculator in the wrong place. I'm looking at the time. Okay, 47.6 divided by 2.4. And I'm sneaking a glance at the dog, seeing if she looks hungry and restless. She's not moving, but you know, she's okay. She just doesn't realize I'm talking about her. Okay, 47.6 divided by 2.4, 19.8333. So I'm going to write 19.83. But I still have to multiply by 100, so it means it's a 1,983% increase. Yes, it went from an old of 2.4 to a new. And of course, why did I have to look there? Bigger number first. Increase. Okay. So that's really big. That's much bigger than that other example, 812.5% increase. So we see about the relative size of these two numbers in the numerator. 365 is a lot more than 40. But even though 50 and 2.4 are both much smaller numbers than 365, 50 is even more a lot bigger than 2.4, then 365 is bigger than 40, if you will. So that's interesting that it's a what if question. So what if that happens? And this is the result. 1,983% increase between these two numbers. Now, I don't have an example where I have a percent decrease that's larger than 100%. So I'm going to try to make one happen. And I hope I'm not going to regret it. Because when I thought of that while I was preparing my notes, I thought, oh no, maybe you shouldn't do that, Doug. Well, instead, I'm going to do it. I'm going to try to do it. So I'm going to leave this here. I'm going to erase this old one and make some room. And I'll just put a squiggly line here. How do I make that happen? Because I want it to be a percent decrease, I need the new to be smaller than the old, but I need it to be a lot smaller than the old. When would that happen? When would the new number be a lot smaller than the old number? Certainly not going to happen with your dog losing weight. Well, we don't want that to happen. I could say I tried growing my tomatoes in April one year, and then I counted how many tomatoes I grew, and then I tried growing my tomatoes in December the next year, and I counted how many tomatoes I grew. That would result in a new, okay, so the second year, okay, I'm going to write this over here. First year and second year. So I'm trying to come up with a scenario where the numbers would actually make happen what I'm trying to make happen with my answer. So the first year, April isn't the best time to grow tomatoes where I live. It's not a good time at all to grow tomatoes where I live, but I know some people who are able to plant their tomatoes earlier than April. Depends on where you live, depends on the weather, and depends, I guess, in the hemisphere that you're in. We're getting into science. Okay, first year, April, and we grew, I don't know, we got 43 tomatoes. And then the second year, we tried it in December, and that really wasn't a good idea. And we got 2 tomatoes. Okay, let's do it. New minus old. New is 2. 2 minus 43 over 43. Is this going to happen? It's not going to happen. I'm trying to make the percentage be more than 100, and it's not going to work. Interesting. I tried. It's a what if. So what if Doug tries this and fails? That's going to be the answer. Okay, times 100. I'm going to finish. Negative 41 over 43. I have to think about this just a little harder, and I'll be able to make it happen, I think. But I can't do it now. I'm running out of time. So I'm finishing this example, and I'm just admitting defeat. Times 100, 41 divided by 43. Negative 41 divided by 43. Button pushing accident. 41 divided by 43. Negative 0.9534, etc. equals negative 953 times 100 equals negative 95.3%. See, I failed in getting my percentage to be more than 100. I'm going to leave that as homework for the students. I'm going to pretend I did this mistake on purpose. Okay, percent, have to put the percent, or I will write a 95.3% decrease. Will that fit in the video rectangle? Yes. Okay, so I managed to get a 95.3% decrease, and that is my answer for my final example in this lesson, and I'm just going to have to be happy with that. I think I did a lot of examples. I am happy with that. And I know that there's a dog who's going to be very happy because in around 1 minute she's going to go upstairs and I'm going to feed her her measly 3/4 of a cup of dog food for her supper. So that was percent change. Thank you for being here for this. It was fun as usual. The time flew as usual. Even if you're a hungry dog, you have to admit that that didn't take long for us to go through. And I will see you next time.